group test. Let's see.
How'd you guys feel about the reading today?
It was the like exams. Like I usually like to see the videos for the not exams. So I was like, it looks so complicated. So
Yeah.
we'll see.
How would you, Camilla?
I think it was pretty easy.
Yeah.
No, that's good.
It was a lot of repetition because like we read about hypothesis already, we read about p-value already, so it was just like going with more details, but kind of not too hard for me at least. But I didn't do the exercises though.
Yeah. Well, we're gonna try and jump into it, see what we can do. Sound good?
Okay.
Yep. Okay, so I open the quiz. So you were saying it starts in number 3, exercises. Okay, so number 3, which hypothesis involves equality?
Just a second, I didn't open yet.
Yeah, so turn off. Yeah, you're good. Ooh, I'm tired.
Okay, I have here.
Okay. Yeah, which hypothesis involves equality? Isn't it the null? No.
I got this. Is the
Isn't it the null hypothesis?
null hypothesis.
All right.
Wait. Yeah, I think it's the null. Because it can also be. No, yeah, it's the null hypothesis.
Okay.
Yeah.
Yep, I agree. So then with 4, which hypothesis do we use to compute the p-value? An alternative hypothesis.
Wait. Incomplete which hypothesis do you assume? Yeah, the null hypothesis.
Yep. No.
Okay, number 5. Suppose the null hypothesis is that uses information to answer the next 3 questions. Which of the following represents the alternative hypothesis for a two-tailed test?
The third option.
The third option. Because that one just can be different, greater, minor, or
Yep. Two-tailed. Cool.
Yeah. Number 6. Which of the following represent the alternative hypothesis for left
The
tail?
first one.
Yep, agreed. Which of the following represents the alternative hypothesis for a right-tailed test?
The second one.
Yep. Wow, you're so good.
Look at Camila. She's on fire. I like my group.
On fire.
Fire.
Okay, remember that we determined the outcome of the question. Which relationship would result in failing to reject the null hypothesis?
When it's a large p-value.
Rejecting. So if p is lower than the level of significance, we reject the null. So if it's lower, so it should be the second one, p-value lower than the level.
I think when the p-value is bigger than the.
Well, my notes is I wrote p-value is lower than the level of significance, then we reject the null.
Oh, okay. So
but
the first
if you
one.
have something else.
No, because I was just thinking, but I didn't write anything about it.
Yeah, I took some notes, so that's what I.
Oh yeah, I have here. If the p-value is greater than the alpha, we fail to reject.
Mm-hmm.
Okay, so
Cool.
the first one.
No.
Yeah.
That's it says.
The
But-
first one, it's greater. Right?
Oh,
Can't remember which one it is.
failing to reject. Oh, well, yeah, failing to
Yeah,
reject.
when p-value is greater. So I think the
Failing
first
to reject.
one.
Yeah, that's you're right. Yeah, because I was looking at the we reject the no, but failing to reject.
Yeah.
Those are tricky, like the failing to reject and then when we reject. Yeah,
Yeah,
you're
it's pretty
you're right.
tricky.
Okay, yeah, that's right. Okay.
Yeah.
Which relationship would result in rejecting the hypothesis? So it'd be the first
Okay.
one, the second one this time.
The second
No,
one,
it's
yeah.
the one. Mhm. Yeah.
Okay. Okay. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They're concerned that the true mean is actually higher than this. Use information for the next few questions. Which of the following would be the appropriate alternative hypothesis?
So it should actually higher.
Yeah, higher.
So the average claim should be 3.
No.
The average claim greater than 1,500.
Yeah, I'd say so.
3, number 3.
Yep.
Camila, what do you think?
The third one?
I think so.
Yeah, we
Yeah.
think so.
Okay.
Which of the following would be appropriate null hypothesis? The average claim is equal. Number 1.
Yeah, the first one, right?
Yeah.
Cool. 9 more questions to go.
The insurance company earns like 90 and calculates sample of uses information type. So we need to plug those numbers on our,
Yeah, we need to
On
find
our-
the Z-score, right?
right?
No,
Okay, let's,
we don't need to yet.
N is 40, X is 15.
I think the first one is the sample size is it's normal because the sample size is large enough, right?
Yeah, that's right.
Yeah.
Theorem of just about your answer to the previous question because of the central limit theorem.
I forgot that.
So that,
But
Yeah,
you're-
because the central limit theorem is when if the sample size is large enough, that means the distribution of the sample mean is normal. And the law of larger numbers means if the sample size is large enough, like I think it's the median and the mean will be the same, something like that.
yeah, you're right.
So I think it's the second one.
Okay.
Or yeah, central limit theorem.
Which of the following is a test statistic as defined in this lesson?
Oh,
I think it's the
the first one, no?
X bar.
X bar, I think that that's a statistic. Yeah, I think the X.
Is it X bar?
I think so too. But I think Apple.
I think it's Z. If I remember correctly, because like the X is just the like the mean X bar. But I think in my notes I have that
I have the
Z is the test statistic, X is the sample mean, U is the population mean, and O is the standard deviation.
Yeah, you're right. I mean, when I wrote the definition, the C only is called the C score. So, like you said, the sample mean is X.
What do you think, Camilla?
So maybe the Z-score.
I'm trying to look here in my notes. Because what we're gonna do is after we find Z-score, we put in the output, and then the area is gonna be our p-value, right?
Yeah.
But I don't remember. Let me see. Because I thought it should be alpha, but he doesn't give the option of alpha.
Yeah, because alpha, I think the test statistic is the Z-score, I think. Because you use the same formula to find the test statistic as you do with the Z-score.
So you think it's Z?
I think it's Z, yes.
Okay, let's go for Z
maybe with
because
Z.
I really have
Okay,
no.
cool. If we get it wrong, it's Camilla's fault. No, I'm just kidding. Okay.
The historical mean
The historical mean of sales receipts at a grocery store is 150 with standard deviation of 40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the hypothesis no 150, alternative 150. She will use a level of significance of 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes x equal 144. Use this information to answer the next 4 questions. What does this score associate with this test? Okay, we just use the normal formula, right?
With the Z-score.
Yeah, the Z-score formula.
Yeah.
Without the sample because there is no a sample number.
Yeah, the 36 is the sample number, isn't it?
Huh? Oh, 36, that's right, you're right. So it's the other one then. Okay, yeah, got it.
So our N is 36, right?
Uh-huh.
Yes. And the standard deviation is 0.05, right?
Yeah.
No, it's 40, no?
That's
Standard deviation is 40. That's the
40, that's my bad. Sorry,
Yeah,
sorry.
it's
You're right. 40, 40. Yeah.
so I got a C of minus 0.9.
I got the same.
Yep. So it's got to be 3 decimals. So it's 0. Wait.
I got 0.0900.
I think when it's 0, we don't have to put because it's just 0.
It's 0. I don't know, should we put 0 or not 0?
I do just in case, but I guess, yeah, you're probably right. We probably don't have to.
Yeah, let's put just in case. What is the p-value associated with the Z-score from the previous question?
So then we just put that in the applet. The Z-score minus.
Yeah.
I need to open the applet. I didn't
0.
open yet.
9.
Did you guys get it?
I got. So we're supposed to highlight the left from the applet, no? From the negative 0.9.
Let me see.
Yeah, let me see.
I get 0.184. So the question is, so the question was to be associated with the Z-score for the previous
I don't know
question.
which one should we highlight.
Yeah, so I don't know.
So the other hypothesis, they should be like they saying that the mean should be lower than 150. So since we calculated 144,
You're right. If the
I get
mean,
everything between.
yeah, like if the mean is smaller than the given value, then we highlight just the left.
I think it's the middle, no?
Wait,
I thought this is my thinking, because isn't the p-value supposed to show the extremes of the data? So shouldn't it be the left and the right?
Because I was thinking about the hypothesis, the alternative is trying to prove if it's lower than
the mean.
the 150. How it is like worded, or like, you know, is alternative is the mean is the alternative hypothesis says that the mean is lower than 150.
What my notes say is that if the alternative hypothesis is lower than the mean, then we have to select the middle and the right side of the apple, which gives us 0.816.
That seems right.
Because I just wrote the same thing that was in the book, online book. And that's what it says. If the given value is smaller than the mean, we have to highlight, it's a right-tailed, so we have to highlight the middle and the right side. I don't know, it can be wrong. That's just what I caught from the online book.
I would think, like, you know, like if I see at the applet, I would think that the area like lower than the mean, that is 150.
But it's not the area. It's like so the mean is 150. The alternative hypothesis that we're trying to prove is 144. So that's smaller than the null hypothesis, right?
Shouldn't it then be only the left side of the applet?
No, because the mean is bigger, so it's the right. I wish I could show you guys my notes, but it's in my book. My notebook, I mean.
So for you, what the area should be? I think that area, like for me, is 0.1841. Highlighting the left side for the applet from.
I see. Yeah, because it's I think because it's a left-tailed test, yeah, you highlight the left side. So it's 0.184. I think that's correct. Now that I look through my notes.
Okay, so just the left side.
Yeah, because it's left-tailed, so you highlight the left. If it was right-tailed, you'd highlight the middle and the right.
But is it saying that it's left-tailed somewhere?
Well, it's not saying that's left-tailed. It's like, you see how the alternative hypothesis, the little arrow thing, is pointing to the left? That means it's a left-tailed test. Does that kind of make sense?
Yes, it does.
I'm pretty sure that's right. Is that what you were talking about, Julia?
Yeah, that's what I think.
Yeah, I understand now. Yeah.
Okay.
I think you guys are right.
Okay. So
now
number 16.104.
Yeah.
Then, so we go to number 17.
Yeah.
So what inference would you make about the null hypothesis for this problem? Reject the null.
I think it fails because the p-value is greater than the alpha, right?
Yeah, the value is greater. So fail to reject the null?
Yeah, I think so.
Yeah, I think so.
You
Yeah, because
choose
p-value
reject.
is greater than the level of significance, they fail to reject the null. What do you think, Paul?
Yeah, I agree with that. I'm pretty sure that's it. Yeah. Yeah.
18. What is your conclusion for this problem? Suggestion and a true proposition.
We have sufficient children that the populations and having sufficient that the population is rising. Evidence in the population. I think the first one, because we're not rejecting the null hypothesis, right? So it means it's right.
Yeah, so I guess it would be the first one because we failed to reject it.
So it says we reject the alternative hypothesis when we have sufficient evidence, and we don't reject the null hypothesis when we have insufficient evidence. Type 1 error is rejected. So what was your, I'm sorry.
Oh, okay, you're saying we have insufficient evidence. So it's not the first one. I think it's the second one, right?
Yeah,
we fail.
Because we did not reject the null hypothesis. We proved it's true. So I think it might be the second one.
Yeah, whatever one says that the mean is 150, I think is the right one. So it'd be the second one.
Yeah.
We have sufficient evidence that the true population is 150?
Yeah, I think so.
Okay.
I think so. I don't know 100% sure why, but I'm pretty sure it is. 19. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
I think it's type 1. Which one involves rejecting the null hypothesis when the null hypothesis is true? Yeah, from my notes, it's the type 1.
Yep.
Yep. Type 1 error is rejecting the truth or reality, so the null hypothesis.
Okay.
20. Researchers decided that instead of using a level of significance of 0.05, we use a level of significance of 0.01. Which of the following will be true?
So it's the second one, I think.
Yeah, I think it's second one too.
The probability of type 1 error will increase. Okay.
All right, now
21.
Last one. Alpha is 0.05. Compute the probability of committing a type 1 error. Oh.
What?
Where's that equation? Is there an equation?
Oh,
wait.
Let me find it.
I don't know if I remember that part.
I don't think I wrote out the equation.
The probability, it's just the 5%, no? I remember the video at the end, he was saying when it's 0.05, is just the probability is just the percentage, the 0.05, the 5%.
But that's the alpha.
Yeah, I see what you're saying, Julia. I was trying to double check that. It makes sense.
Yeah, it does make sense because I don't think there's an equation for that.
It's just 0.05, that's the 5%.
I think you're right.
I think so. Yeah, that's what I think.
Let's submit.
All right.
Let's see what we got here, guys.
And okay, 82%. Not bad.
95%. Which one was wrong?
Wait, what did you guys get?
18 was wrong,
18 was wrong. What is your conclusion from this
and
problem?
21 was wrong.
Wait, what score did you guys get?
91.3.
Mine,
Oh,
mine
okay.
95.65.
Oh, what the heck? I got 82%. What the?
What? Did you answer the first two questions? You know, like
Okay. I got 21 and 18 wrong.
the
Oh.
21, I thought we said 0.05. That was the 5%. 0.05.
Yeah, I put 5.
Oh,
Oh,
did you
no,
get-
it's because, yeah, you need to do it in decimals.
So I should have put
0.05.
0.05.
Did you get
No,
that right?
just 0.05.
Oh.
0.05.
The same.
Oh, so it was the same answer.
Oh, I put that in wrong too. Okay.
I put 5.
And then they want you to put in the same decimals. Because you remember the video that it says that, you know, the probability is the same. So if this 0.05 is 5%, but you have to do it in decimals, so it's the same 0.05.
So what do we decide to put for number 4?
For number 4, let me see.
Oh, I clicked the wrong one.
No hypothesis.
Oh, geez.
Oh.
We talked
No.
about them, and I told you guys that was what I thought. That's
Yeah.
weird. All
What
right, well,
did you guys get number 18 right?
18.
I didn't get that one right now.
No.
What did you guys put for 15?
Minus 0.900.
Oh, I didn't put the minus. Dang it.
Oh, yeah, minus one.
There's a problem.
Mm.
I'm sorry, Paul.
No, it was my bad. I just wasn't paying attention. I'm really tired today.
You're working, so.
That's funny. Wow.
Mm.
Sorry, teacher. Do we think 18?
I don't-
Do you think
Honestly, I don't think he watches this.
That'd be
Seriously,
to watch?
it's so long and so many students.
It's boring to watch.
He uses spots, you know, like probably he goes like 2 seconds and like, okay, they do it.
Yeah, he probably knows
Yeah,
just like the back of his hand, and he's watching us like struggling through it. So would 18 be number 3 then?
18, number 3, probably.
So we have insufficient evidence that the true population is less than 150, which is also another way of saying that 150 is correct.
Mm-hmm.
Yeah, maybe.
Yeah.
He should give us the answers, then we would be able to
Yeah, no, what would
correct
you
ourselves better
Yep.
Yeah, well,
next time, guys.
I know.
yeah.
We'll see. Okay, guys. Well, thank you very much for being here.
Way to go, team.
Have a good night, guys. Good
Bye.
rest.